In this example, we are doing an uninhibited growth model. So we've got a population of a colony of squirrels that obeys the law of uninhibited growth. If there are 3,000 squirrels initially and there are 4,500 after 1 month, what is the size of the colony after 8 months? How long until there are 20,000 squirrels? So once you get past the ridiculousness of this question, we can dive in and actually use the uninhibited growth model. And what that looks like in our textbook is this: n of t equals n sub 0 times that magical number e to the power of kt. So really, in defining all these, n of t, that's just function notation. So this is the population after a certain amount of time. N sub 0 is the initial amount of squirrels in this case. E is, again, that magical number. We can calculate it with a calculator. We're just using second, and then the division sign is approximately 2.718, so that's just a constant. Oops, sorry about that. K is also going to be a constant, but we don't know what it is yet, and time will vary. So we need to figure out the growth rate here of the squirrels, and that's the first thing that we're going to do, because we're given some clues. We have 3,000 squirrels initially. After 1 month, there's 4,500, right? So n sub 0 will always be 3,000. Okay, that's not going to change at all. And our clue was that we had 4,500, right, squirrels. That's a lot of squirrels in 1 month. So extracting that part of the word problem and writing that part down. So we're going to take this 4,500 and we're going to have, that's their population after a certain amount of time. So this is t equals 1, right? So we're going to plug that stuff into our equation in the right spot. So again, the initial amount's 3,000, so that's not going to change. 3,000 goes there. E is that constant. We're not going to change that. K, we don't know. We're looking for the growth rate. And T will be 1 in this case. So after 1 month, we know the population in the future is 4,500. Right? Okay, so this is enough information. We had that one part of the sentence in the word problem, and we're going to try to figure out what K is. All right, so to do that, we're going to isolate K. I'm going to divide both sides by 3,000. Just like solving for a variable. We've done examples like that before. 4,500 divided by 3,000, that's 1.5. And that equals e to the power of k times 1, which is just k. All right. Now to solve this problem, we need to convert this into a logarithm. So the base of the logarithm will be e because the base of the exponent is e. So this is the natural log. The natural log is just the log base e of any number, let's say x, is really just the natural log of x, ln, some people say, but it's actually just natural log of x. So the natural log of 1.5 equals k. So I had made another video of the circle of logs. That would be e to the power of k equals 1.5. If you're struggling with that, you can go back and watch that video. But basically, this and this are equivalent, and this is easier to deal with because I can just plug this part into the calculator. And that's exactly what I'm going to do. So I'm going to take the natural log, and that's right down here. There's an ln button, so I'm going to press the natural log of 1.5, close parentheses, and I get 0.4054, and it trails off. I'm going to round 3 decimal places. I get 0.405 equals k, approximately, of course. Okay, so that's going to help me out because now I can start answering some of the questions. It says, what's the size of the colony after 8 months? Well, now that I know the growth rate, I can just plug in t equals 8, because in 8 months, that'll tell me how many squirrels there will be. And that's exactly what I'm going to do. So, to figure that out, my initial amount is 3,000. E has not changed. K I just found to be 0.405. And now time will be 8, because in 8 months, I want to know the population. So if you wanted to put something here, you can just calculate that, and that'll be the number. This is really the population n of 8, really. N of 0 would just be the initial amount, 3,000. N of 1 would be after 1 month. N of 8 is after 8 months. So what will this be? If I plug all that in the calculator, so I got to take 3,000 times e, and e is actually just right next to or right above the division symbol. So I'm going to hit second, and then the division symbol, and that pops up there. And then I need to the power of, and since I'm raising it to a power, I need to put the whole exponent in parentheses in this old calculator here. 0.405 times 8. and I get 76,601.16. So I'm just going to keep that as 76,601 since we're talking about entire squirrels. So that equals 76,601. All right. So n of 8 is that. That's how many squirrels you'll have in 8 months. All right. Next part of the question says, how long until there are 20,000 squirrels? How long until there are 20,000 squirrels? So now we know how much there will be in the future, 20,000. And the question is asking, when will this initial amount of 3,000 squirrels grow to be at this particular growth rate? When will that take, or how long will that take to get 20,000 squirrels? So I have my growth rate from before, and I'm just trying to find t now. And I'm going to do that in the very similar way that I found k earlier. I'm going to isolate t by divided by 3,000. And I just plug 20,000 into my calculator, divided by 3,000. If I do that, I do this, divided by 3,000, and you get 6.6 repeating. I'm going to write that down exactly, 6.6 repeating, time equals e to the power 0.405 t. All right. And then I am going to change this to a logarithm. So this will be the natural log, since it's base e here, of 6.6 repeating equals 0.405 t. Now to isolate t, I can just divide both sides by 0.405. And I will have the time that it will take for that colony to grow to 20,000 squirrels. So plugging this into the calculator, we have the natural log of 6.66666, I'm just going to round it to that, divided by 0.405. And I get 4.68 approximately, because I've rounded a little bit. So 4.68. So to answer my question, in 4.68 months, I guess the colony will be 20,000. 20,000 strong. It'll be 20,000 squirrels in 4.68 months, approximately. I hope that one helps you with exponential growth for populations.